Okay, so section 10-4 is the next section we're going to talk about, and it is ellipses. And here I've tried to show you kind of morphing. So we have a circle which has one center. An ellipse, however, has a focus point and a focus point. Two of them together are called foci. And as you see, as the foci get further and further apart, what happens to the ellipse? It gets longer and shorter. Very good. Okay, this next diagram is going to show us all the parts of an ellipse. It is rather a complicated diagram, so I would ask that you just sit and listen while we go over all of the parts, and then you can draw it. Okay, so here we have an ellipse. This ellipse is horizontal. The axis that goes through the horizontal is called the major axis. The minor axis is the shorter side. In this case, the center of the ellipse is at the origin here, 0, 0. The locations where the ellipse intersects the major axis is called a vertice. So we have a vertice here, we have a vertice here, a vertex here, a vertex there. The plural is vertice. Because this is centered around the x-axis, the coordinates we're going to call A. So the variable we use for the vertex is A and minus A. And the location for the y is 0. On the minor axis, we call these co-vertices. Their coordinates are 0 because the x-coordinate here along the y-axis is 0, and the y location is b and negative b. Okay, we have vertices along the major axis, co-vertices along the minor axis. The variable for the vertex on the major axis is a. The variable for the co-vertice is b. And we have two more points on here we haven't talked about, and that would be the foci. We label them F1, F2. This is the focus. That's the focus. And here I have written in pencil, it's kind of light. The variable we use for the focus is c. So this is negative c comma 0. Okay, again, it's on the x-axis. And this one is positive c comma 0. So a summary, the vertices of an ellipse, their coordinates are a comma 0, negative a comma 0. The coordinates for the foci of an ellipse, F1 and F2, are c comma 0 and negative c comma 0. And the co-vertices are 0 comma b, 0 comma negative b. So again, on the major axis contains the foci and the vertices. The minor axis contains the co-vertices, and the minor axis and the major axis are perpendicular to each other. Now I'm making a big point of this because not only can you have horizontal ellipses, but you can have vertical ellipses. So we're going to get to vertical ones in uno minuto. So the standard form for the equation of a horizontal ellipse is this. It's x squared over a squared plus y squared over b squared. Does anybody remember where I got these a's and b's? Look in your notes. Look at the diagram. It's the same a's and b's from the diagram. The vertices and the co-vertices. Thank you. So the a is the coordinate for the vertice on the major axis. The b is the coordinate for the vertice on the minor axis. And here's an example. X squared over 16 plus y squared over 4. I can tell equals 1, always equals 1 in ellipses. I can tell that this is a horizontal ellipse because the a squared is bigger than b squared, which means that it's longer in the x direction. So if the previous ellipse was horizontal, this one is vertical. Thank you. So the vertices always stay with the major axis. The co-vertices always stay with the minor axis. The major axis is the longer one. So in this ellipse, which axis is, oh there it says it right there, duh. Which axis is the major one? The y-axis. And the minor axis is the x-axis. So that means that this intersecting point is 0, a. This intersecting point is 0, negative a. Okay, again, the a goes with the major axis, the b goes with the minor axis. And here I have F1 and F2. Question, James? Where did I get what 6 from? Negative 6 and 6. Those are B's. We'll get to that. Right now I'm just drawing them. They are the intersecting points. Okay? I showed you previously the standard form for ellipses that were horizontal. Here's the standard form for ellipses that are vertical, and it's slightly different. In the horizontal one, it was x squared over a squared. Now it's x squared over b squared. Okay, remember what I said. The vertice is variable is a, and it always stays with the major axis. So in this case, this is vertical, so that means the y is the major axis, so the a squared goes under the y squared, and the b squared goes under the x squared. And so here would be an example. Right, since, just a little note, again, I'm trying to hammer some of this stuff home. Since a is always on the major vertice, and in this case, if it's under the x, then it's horizontal. A is always is a major vertice. If it's under the y, then it's vertical. So let's do one more thing for this section, and that's going to be finding the foci. So here I have an ellipse. Is it horizontal or vertical? Horizontal. Thank you. So that means that the coordinates of this are going to be a, 0. What's going to be the coordinates here? Negative a, 0. Up here, so this is the minor axis, so this is going to be 0, negative b, and this one's 0, positive b. Okay, the foci are somewhere in here. So this is negative c, 0, this is c, 0. Okay, so I know that the coordinate here is actually 10, 0, and this is 0, 4. Because I counted it. What? How did I know what?
How do you already find the book?
I didn't.
What's this?
Well, I just drew them in there. I don't know what the coordinate is. That's what we're going to do. We're going to find these coordinates, okay? So I'm going to tell you how we do this. So I have B. So what's the length of this segment?
4.
Okay, let's use the variables though. It is B. What is the length of this segment? Obviously, this is one we don't know.
C.
It is C. Now, let me tell you that the length of this segment is actually, don't guess, it is A. If I were to take this segment, lay it down flat, it would go from 0, 0 to A. So now, what did I just draw? A triangle. And whose theorem did we use last year in geometry? The Pythagoras' theorem, and it was called the Pythagorean theorem. And if we knew two sides of a triangle, we could find the third one. Now, this is going to be a little bit different because in this triangle, which one is the hypotenuse? A. Okay? So it's actually going to be, if we're going to write it true to Pythagoras, it's going to be A squared equals B squared plus C squared, right? We know A, we know B. What we're looking for is C. So I'm going to isolate C. So the actual equation I'm going to use is C squared equals A squared minus B squared. Okay? I wanted to show you how I got that instead of just writing this down, because if I just wrote this down, you guys would all freak out and say, no, 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 it's plus. So let's find out what C actually equals. So I have C squared equals 100, which is 10 squared, minus 16, which is 4 squared. It's equal to 84, and the square root of 84 is equal to 2 root 21.